All right, so combining normal random variables. So far, we have concentrating on finding rules for means and variances. Of random variables. If a random variable is normally distributed, we can use its mean and standard deviation. To compute probabilities. The earlier examples of young women's heights on page 357 show the methods. Should say what if. What if we combine two normal random variables? Okay. So example A says a computer simulation. There's not work with this. We're just looking at the graphs, okay? So we use a Fathom software to simulate taking independent SRSs of 1,000 observations from each of the two normally distributed random variables x and y. The figure below shows the results. The random variable x is n 3.9. So remember that's mean standard deviation for x. And y is a normal distribution with a mean of 1 and a standard deviation of 1.2. What do we know about the sum and difference of these two random variables? The other histograms below, I think it says came. Should be came. I told you there was a lot of them. From adding and subtracting the values of x and y for the 1,000 randomly generated observations, should say from each distribution. All right. So here's our plots. You guys see them. This is x and y. So this is x by itself. The top is just x by itself. The bottom is just y by itself. This is the addition of x and y. This is the subtraction of x and y. Okay. Does everybody see that? So it shows you that right here. X, y, sum, difference. All right, so let's summarize what we see. What is the shape of the sum of x and y? So what's this shape? So this is also approximately normal. Why can I say that it's approximately normal? What do you know about these two? What'd they tell you? That they were normal, right? If these two are normal, then these have to be normal. Does that make sense? All right, so same thing, difference x or y. You guys would have said roughly symmetric because we haven't talked really about anything else. But they're actually approximately normal because their x and y, which makes them up, is approximately normal. Okay. Where is the center of the addition? Where is the center of the addition? So the addition is the one on top, your scale's down here. What does it look like? 3 or 4. So let's say approximately 4, and here's y. So your mean of x plus your mean of y. Your mean of x from the top, it told you that this was x. X was normal 3 and 0.9. I don't want you to think that I'm doing this weird, like just making stuff up. 1 and 1.2. That was from your problem. So the mean of x was 3. The mean of y was 1. So that would mean that it would be 4. So you're absolutely right. So if you look at the difference, the center of the difference is going to be approximately 2, which would make sense because the mean of x minus the mean of y is 3 minus 1, which is 2. And then what's your spread? What do we know about the spread regardless of whether they're adding or subtracting? It's going to be the same. Remember, both spreads are going to be the same because we would do to find the variance of, the addition or the sum. I should put S, but it's okay. We would do the variance of x plus the variance of y. The difference, we would do the same thing, x plus y. So they would have to be the same. It's the same formula. Okay, so that's all they want you to see. 2 more pages, y'all. One example. All right, so as the previous example illustrates, a little bit of writing right here. Any sum or difference of independent random variables is also normally distributed. So the mean and standard deviation of the resulting normal distribution can be found using the appropriate rules for means and variances. So like I said, if the regular ones, X and Y, are normal, then your sum and difference will also be normal. All right. So give me some sugar, sums of normal random variables. So the only thing that we're going to do differently in this is it's going to ask you this right here. What is the probability that it tastes right? Okay, so we're going to do a probability this time. How do we do probabilities? We do it in our calculator. How do we do them? Normal CDF. So we're just adding that back in. So we've already done this. Now we're just doing it with the difference or whatever. So Mr. Starnes likes sugar in his hot tea. From experience, he needs between 8.5 and 9 grams of sugar and a cup of tea for the drink to taste right. While making his tea one morning, Mr. Starnes adds 4 randomly selected packets of sugar. Suppose the amount of sugar in these packets follows a normal distribution with mean 2.17 and standard deviation of 0.08. So we can write that just to show it back out one more time. A mean of 2.17 and a standard deviation of 0.08. All right. So how can we tell if his sugar tastes right? This is just for a 1 packet. How many packets did he put in? 4. Are they different each time or are they the same? But are they different? They're different packets of tea? I mean, not tea, but sugar? Essentially, they should be the same, right? If we're using the same brand, you know what I'm saying? Like if we're using Splenda, the Splenda packet should be pretty much follow the same path. Okay. So we want to do the mean of the total. So we're going to do the first packet plus the second packet plus the third packet plus the fourth packet. So 217, 217, 217, and 217, which will give us a mean of 8.68 grams. Sorry, I'll get that out of the way. 8.68 grams. Again, why are we doing this? Because to find the probability, we have to have the upper, the lower, the mean, and the standard deviation, right? Okay, so that's why we're doing this. We got to find the mean and the standard deviation so that we can put it in normal CDF. So to find the standard deviation, we have to do the variance first. So we're going to do the variance of X1, first packet, plus the variance of the second packet, of the third packet, of the fourth packet. So our standard deviation of one little packet is 0.08. So we need to find the variance of that 4 times and add it together. When we add that, we get 0.0256. So to find the standard deviation, we take the square root of that, which gives us 0.16 grams. All right, so again, why did we have to do that? To be able to find the probability and to be able to put it in normal CDF, we need the lowest amount of sugar he'll take, the highest amount of sugar he'll take, the mean of all the sugar packets, and the standard deviation of all the sugar packets. We need to write a probability statement. So the probability is that it's between 8.5 and 9 grams. 8.5 less than or equal to your total sugar amount less than or equal to 9. And we use T because that's what it told us to use, the total. You said we use normal CDF. We have to define everything. So we start with lower. What's the lowest amount of sugar he'll take? 8.5. We go to the upper. What's the highest he'll take? 9. We do the mean. What was the mean that we found of all 4 packets? And then we do the standard deviation of all 4 packets, which was 0.16. When you put that in your calculator, you get 0.8470. So then write a probability statement for it. What's the probability that Mr. Starnes' tea tastes right? There is what? We're going to say 85% chance. You can write it like this. I just like to do different ways to write it to let you understand that you don't have to be exact, okay? So there's about an 85% chance. What? Yep, that Mr. Starnes' tea tastes right. This one is pretty much exactly the same. The only thing is we're going to do a difference instead of a total. Okay, so same exact thing. We're looking for the probability, but we're doing a difference instead of a total. So last page. The diameter C of a randomly selected large drink cup at a fast food restaurant follows a normal distribution with a mean of 3.96 and a standard deviation of 0.01. The diameter L of a randomly selected large lid at this restaurant follows a normal distribution with mean 3.98 and a standard deviation of 0.02. For a lid to fit on the cup, the value of L has to be bigger than the value of C, but not by more than 0.06 inches. So that's where your probability comes right here, not more than 0.06 inches. What's the probability that a randomly selected large lid will fit on a randomly chosen large drink cup? So your other normal that I didn't put down was 3.98 and a standard deviation of 0.02. So we need to make sure that the difference, so it told us that the difference is not more than 0.06 inches.
Y'all gotta bring those back Monday with you, filled out, and if you're a bus rider, it goes to your bus driver, and you don't bus today. All right, thank y'all.
Thank you. So here's the question, which one goes first? Do I do lid minus cup or do I cup minus lid? What's it say? Tells you right here.
Lid minus cup.
Yes. The lid has to be bigger than the cup. So we want it to be a positive is what we want. So what was your mean of your lid? This was cup. This was lid. So the diameter of the cup follows a normal 3.96.01. The diameter L of a selected lid follows a normal distribution of 3.98.02. So which one's your lid? 3.98. We want to subtract 3.96, which gives us a difference of 0.02. This is what we're going to use in our probability, our normal CDF. We need to find our variance of the difference, which is the same thing. It doesn't matter on this one which order you put it in because you're adding them. So 0.01 squared plus 0.02 squared. And I know that is backwards because the lid should come first, but you're adding, so it doesn't matter what order you put it in. So if you're a little bit OCD about it, flip it around and it's fine. But that gives you 0.0005. So then your standard deviation is the square root of that 0.005, which is going to be 0.0224. So then our probability statement, it can't be more than 0.06 inches, but what I need you to realize is it also can't be less than what? 0. It has to be a positive number, right? So 0 is a perfect fit. There's no gap. That's a perfect fit. Less than or equal to the difference, less than or equal to the max it can be is 0.06. So remember, 0 is a perfect fit. You don't want anything less than that. That's why we're using 0. So we're going to do normal CDF. What is our lower going to be? 0. What's our upper going to be? Our mean, 0.02, and our standard deviation. We're going to put that in our calculator, and we get 0.7770. And then we're going to interpret that, and that's all we're going to do. What's this say? There is a what? 78% chance that what? Large lid will fit on a large cup. And here we should say a randomly selected large lid will fit on a randomly selected large cup at a fast food restaurant. Is that a good thing or a bad thing? Bad, because 25% of the lids aren't fitting. So what should we probably do? Get better lids. Get a better vendor, cup vendor. That's it, guys. That's what I wanted to finish. So stay on Zoom for a minute. Mary Kate, you can go ahead and go. But stay on Zoom for just a minute. And let me explain what the rest of the week is going to look like, okay? I'm going to stop.